In this video, we're going to look at how some evidence that seemingly is unrelated to the atom is going to help us refine our ideas for what atoms are like. Just to review some of the things we talked about before, atoms absorb energy, and when that happens, they become excited. That's the technical term for it. And they are unstable in that form, and they de-excite, giving off a photon of energy. Photon is a particle of light, literally. The normal state that we find atoms in are called the ground state of the atom, and the absorbed state is called the excited state, which just kind of stands to reason. So this is how atoms go about exchanging energy. They absorb, they become excited, they give off that energy again as a photon of energy, they go back to the ground state. All right, and it turns out that the difference in energy between the ground state and the excited state is exactly the same as the energy that caused the change in the atom. Now that, again, kind of stands to reason. You put in energy, the change in energy of the atom is equal to the amount of energy you put in. It's kind of like bookkeeping, make sure that whatever we put in, we actually get a change from. All right, so now the same thing happens when we de-excite. So we're going to start seeing these kind of diagrams here. Here's the ground state on a graph of energy. The ground state, we excite the atom up to here, to the excited state, but then when it de-excites and it drops back down, it gives off a photon, and that photon is exactly the same as the difference in energy between these two states. We took energy to get up here, we get back exactly the same amount of energy when it comes back. Again, it's almost like the law of conservation of energy is applying here. Now, hydrogen is an example of that. And this has been known for a long time before anybody understood much about atoms, that when you excite hydrogen, for example, in the sun, hydrogen is excited because it's very hot in the sun. It gives off a very characteristic set of 4 colored lines. They are at 410 nanometers, a kind of purplish line, a blue line at 434 nanometers, a green at 486, and then a red line at 656. Hydrogen always gives this off, and hydrogen, in fact, is the only one that does. This is called the emission spectrum of hydrogen because this is what hydrogen gives off. As you might assume from the fact we have to put a modifier in front of spectrum, there are other kinds of spectra as well. Each one of these is a kind of photon. So what we can conclude from this has to do with the inner structure of the hydrogen atom. Okay, so since these photons are produced when atoms de-excite, and the energy depends on the excited and ground states, then there are only certain possible excited energy states for hydrogen. Now this is a surprising conclusion, not based on the evidence, but based on what we see in everyday life. Okay, so here is a diagram, again, energy on this side, ground state here, and here are the 4 transitions or 4 changes that we can see hydrogen undergo. Ground state, and then there are 4 excited states, a lower level, a slightly higher level, higher, and then yet higher level. And these are the changes that the atom undergoes. It goes up to this excited state, back down. It can go from this excited state to this excited state. It can go from the ground state all the way up to this one and make all these different transitions. And each of these transitions corresponds to a different photon, a different energy of light, and so we see the emission spectrum for hydrogen. All right, we're going to stop here, and we'll pick up talking more about what this tells us about hydrogen.